Today, I want to discuss how to read drawings. And while we do that, we'll also understand कि हमारे bridges में क्या components generally होते हैं. Most of the bridges में. Whenever you read the specification of a bridge,
Hmm.
it is written something like this. Design and construction, including proof checking from NIT of 70-meter span, major permanent steel girdle bridge with RCC decking on open foundation over this location. 70-meter means length of bridge is 70-meter. But this 70-meter, it's not where does it start from? So it starts from this place, this point over here. Starts from this point over here, from this point to this point. It is not the end of this truss, but from this line. And these two lines are called as center line of bearing. So as you can imagine, bridges have two parts: superstructure, which is the thing on which your vehicle travels, and substructure, which is the thing on which your superstructure rests. Between superstructure and substructure, there is this component known as bearing, which is not clearly visible here, but it is this black thing over here. Okay, so bridge rests on a bearing, and bearing rests on substructure. The center line of bearing is what we use to measure the span of a bridge. So as you can see here, 70-meter the center of bearing. Now, if this is a single span bridge, because there are two components of substructure, left abutment and right abutment. When we have a double span bridge, we'll have a third component as well, something here and then another truss, right? So similarly, bridges, this is a steel truss bridge. You remember this description it had shown? कि क्या major permanent is it's a permanent structure. It is not going to be dismantled anytime soon. Major is usually when it is present over a major river like this, present over I think a tributary of Chenab or something. That is why it's major. And steel girder should not be steel girder. This is a typing error. It is a steel truss bridge. Truss is this frame what we have studied also in our courses.
Hmm.
This is a truss arrangement. There can also be a concrete bridge, which is shown in drawings over here.
And are you saying something?
I'm searching for
Concrete.
GAD, but I cannot find one for. Okay, one doesn't matter. It is. Oh, wait. And it will also show you what a three-span bridge. This is a concrete bridge, and it has one, two, three spans: left abutment, right abutment, and two piers. Usually, pier is something which is in the middle spans,
Hmm.
and it does not hold soil on either side of it. There is no soil on left side or right side of here, but on abutment on one side it has to hold soil. Okay. So this particular drawing which we are looking at right now, it is called as a general arrangement drawing, GAD. It shows general arrangement of your truss, your foundation, and its second part is this view where it shows you the truss from top and the cross section of truss. You see, it says section 1 1 over here, and this is what is section 1 1. If you cut the truss here and look at it from this side, it will look like this. Before we come to this picture, I'll explain this a little bit. Whenever you are making a GAD, you have to, or when you're looking at a GAD, some things which are very crucial and which need to be mentioned are these things: formation level, which is also sometimes called as FRL, or road top level. Not road top level, but deck level. This is the level of the top of slab of the bridge. Founding level is the level at which your foundation rests. Already told you what bearing is. Now this is expansion gap, another important term. So you see my this steel thing, it ends here. Concrete thing of the substructure starts at this position.
Huh.
So there is a gap in between your truss and and this is the concrete slab on top of truss. So there is a gap between the concrete slab of truss and concrete of substructure, this portion. That is called expansion. As the name suggests, it is used. It is not used, but it is there because we need to take into account expansion of concrete,
Hmm.
so that when concrete expands, it has some room to expand. Otherwise, there will be cracking in concrete.
Hmm.
So this expansion gap is usually very small, 50 to 60 mm, and it is just there so that the concrete can comfortably expand. So now you have done simply supported beams, right?
Huh.
So trusses are simply supported beams, which means that their one support is fixed and other support is free. You getting it? And that is why it is written as fx fixed here and fr free here, which means that, so how do we maintain fixed or free? That is done through the bearing. The bearing is fitted on the substructure and it is connected to the superstructure. But its connection to the superstructure is also is actually what makes it fixed or free or whatever. We'll get to like a little bit more detail about bearing at a later stage. Now, let us first. Today we'll understand what substructure is. Before we do that, there is a lot of stuff here which is chainage and reduced level. And usually this table here, chainage and RL reduced level,
Hmm.
it is used to show the cross section of the bridge. This line is called as cross section, and what they do is that they take total station and they get the points of the river cross section at various locations, and these are the locations at which they took the points, and then when they took them they joined them in AutoCAD and made this cross section. So this is what the table is used for, and accordingly they plotted this whole thing and they fitted the truss on this cross section. When they are deciding the span of the bridge, like how long the bridge should be, they have to take care of a few things. First is that this distance from the edge of foundation to the edge of cross section, it
Hmm.
should at least be 3 meter. Otherwise, there is a concern usually कि वो फिसल जाएगा या this stuff can wash away or something like that.
Hmm.
So that distance is usually 3 meter. And the second consideration that they have is what is the level of this bridge that they want to achieve. क्योंकि यूजुअली पीछे से रोड आ रही होगी, तो अगर रोड इस लेवल पे आ रही है तो ब्रिज हम ऊपर तो बना नहीं. एंड थर्ड इज कि अगर पीछे के रोड का लेवल इज नॉट एन इशू, then this for example in this case they could have constructed the bridge at this level as well. अगर इस लेवल पे ब्रिज बना रहे होते then the span would have been 70 की बजाय 35 or 40 मीटर का होता. It would have been okay. But specifically in this case, their road level is somewhere here, so they have to make it like this. Now, these are the water levels more. The most important of them, actually two of them are LBL and HFL. HFL is highest flood level. इसका हाइड्रो में पढ़ाया होगा कुछ. So they'll teach you in HFL. No, not water resources. Very self-explanatory again. कि
Uh-huh.
इस रिवर में किस लेवल तक मैक्सिमम फ्लड आ सकता है. एंड एलबीएल इज लोएस्ट बेड लेवल. सो जो रिवर का क्रॉस सेक्शन है, व्हाट इज द डीपेस्ट इट गोज, ठीक है.
Hmm.
एंड एलडब्ल्यूएल इज लोएस्ट वाटर लेवल. दिस इज यूजुअली गॉज्ड फ्रॉम एक्सपीरियंस बाय आस्किंग लोकल्स कि यहाँ इस रिवर में पानी कितना नीचे जाता है. दैट इज हाउ दे एस्टिमेट. वो या फिर दैट, या फिर इफ दे गो देयर इन विंटर, विंटर में यूजुअली फ्लो कम होता है, तो पीक विंटर के टाइम पे जो लेवल होगा पानी का रफली उतना ही एल होता है, उससे कम पानी कहाँ जाए. नाउ वी आर गोइंग. ओके, वन वन क्विक थिंग विच नॉट मेनी पीपल नो कि whenever you are making this GAD, you have to stand on upstream of the bridge and look at the bridge, and what you see on left will be shown on the left side here. समझ आया?
Can you?
ये देखो, दिस इज द प्लान ऑफ another bridge. ठीक है, this is the river, this is the river, this is all this surrounding area. This is downstream is the direction in which the river is flowing. So river is flowing from this direction to this direction, from this to this. Upstream is this, downstream is this. River is flowing from here to here. Now we want to make this GAD of the bridge. GAD is this general plan of how the bridge would look like. अब अगर मुझे GAD बनानी है तो मुझे लेफ्ट साइड पे कुछ दिखाना पड़ेगा और राइट साइड पे भी दिखाना पड़ेगा. अब मैं लेफ्ट साइड और A2 on left side, because if I stand here and look at the bridge, A2 will be on the left. If I stand here and look at the bridge, A1 will be on the left, है ना? So there is a convention कि whenever you are making this GAD, you have to stand on upstream side of the bridge and look at whatever you see on the left side will be shown as on the left. So that is what I was. So this is so, and generally what they do is कि to avoid any क्योंकि ये not many people know this, इसलिए वो गलती करते हैं. इसलिए instead of saying कि वो left side या right side, अगर बाय रूल करो तो फिर इवन इफ दे हैड रिटन लेफ्ट साइड एंड राइट साइड हियर इट वुड हैव बीन ओके, बट दे राइट द नेम ऑफ द एरिया ऑन और द रोड ऑन द लेफ्ट साइड एंड द राइट साइड टू मेक इट मोर क्लियर, व्हिच इज द प्लान ऑफ. ये व्यू समझ आ रहा है ना किसका है? टॉप व्यू और ट्रस्ट का. इसमें देयर इज नो एडिशनल nomenclature that we need to look at because everything is already in the other drawing. Here we can have a look at it, the cross section कैसा. So carriageway, these is all codal requirement. IS code के हिसाब से this is a 2-lane bridge. 2-lane means one way, 2 traffic clear carriage. Then we have a crash barrier 450 wide. Then we have a footpath 1500 and we have an RCC railing 375 This is our cross section of the bridge, and this is our truss, like you can see. Finally, there is this service arrangement. It's like a bracket, L shape. Now what you do is that because at times you have seen power lines and water lines on bridges. So when this is made on a bridge, when you have to bring electricity or water from one side of the bridge to the other side, you run the power line or line on these brackets, so that you do not disturb anything on inside the bridge. This is again, this black thing is bearing, like I had told you. Now this is very interesting because the bearing is, even though you can see it here, कि bridge हम तो जब सिंपली सपोर्ट पढ़ते हैं तो वी हैव अ सिंगल लाइन, उस पर सिंगल सपोर्ट होता है और वैसा होता है. बट एक्चुअली देर आर 4 bearings in this bridge. In fact, any truss type of a bridge will have 4 bearings. 1, 2, 3, 4. जब I have written कि fixed bearing है, it does not mean कि ये दोनों fix हैं. This is the fixed side of the bridge. This is the free side of the bridge. But both these bearings are not restricting movement in both directions. I'll show you later what that means. But for now, understand that there are 4 bearings in this bridge, which is shown here. And which is also clear. This is one side of the bridge, right? So
ब्रिजेस ही बनाते हैं या फिर ऐसे कंटिन्यूअस बियरिंग टाइप की कोई भी टाइप की भी कोई
कंटिन्यूअस बेयरिंग नहीं होते हैं, बट इफ यू लुक एट प्लेट गर्डर ब्रिजेस, then you'll have many bearings. You have like 6 or 8 bearings on one side only. Generally, these double lane bridges, which has basically it depends upon how many trusses may usually they'll only be 4 bearings unless you have 2 trusses side by side. You understand? अगर ये वाला चीज एक और होता है इसके साथ में ही, then there will be 2 more bearings, but that will be only for those the like 2 more bearings for that new truss. But इस simple truss में there are only 2 bearings. There are alternate arrangements where you can have one bearing here, one bearing here, and another one in the middle. That is a different kind of a bearing arrangement. That is also there, but that is usually more expensive. तो लोग यही वाला करते हैं जिसमें 2 ही bearing लगे. ठीक है? Now we are coming to the substructure abutment. First, we'll look at the abutment which was shorter than height. So there, as you can see, there are 2. This is the shorter, this is the longer one. We'll first look at the longer abutment will be exactly same. There is no difference apart from the dimension.
Okay.
So this diagram here, it shows you what all components are there in an abutment, which will also bring us to our first estimating case. The abutment में you have your footing, which is this trapezoidal portion,
Hmm.
RCC footing. ठीक है. Abutment, then there is this shaft. So this, it's written as abutment here. Some people usually call the entire thing as abutment and call this thing as abutment shaft or wall or abutment wall, but it only refers to this portion till here, from here till here. उसके ऊपर this like trapezium thing again, it is called as abutment cap. This wall which goes up from the cap, it is called as dirt wall. This box here, it is the pedestal, and this cross is the bearing. So if you look at this cross section, this is the cap, this is the pedestal, and this is the bearing. समझ आया? तो pedestal throughout नहीं होता उसकी width में, उसमें बस bearing के नीचे होता है. Basically bearing rests on pedestal and pedestal goes on top of the cap. So this level is called as abutment cap top level. This is foundation level again. Now there is also a wall here which is in this direction from here to here, which is called as return wall. It will be clearer in this next diagram. This is the plan at foundation, which means that if you cut the abutment here at this level, what will you? This is the abutment wall, this is the foundation, and this is the return wall, which I was telling you. So return wall is only present at the ends. यहाँ पे ठीक है, पीछे की तरफ सॉइल की तरफ होता है. इट इज एक्चुअली मेकिंग अ सी शेप. अगर टॉप से देखोगे अबटमेंट को, सिर्फ अबटमेंट को, तो दिस इज योर वॉल एंड दिस इज कैप. दिस इज द रिटर्न वॉल, ये वाला. इसके बीच में सॉइल फिल होता है. दिस इज द अबटमेंट रिटर्न वॉल. जब सॉइल पूरा फिल हो जाता है यहाँ तक, इसके ऊपर दे पुट अ कंक्रीट स्लैब, जिसको कहते हैं अप्रोच स्लैब. So whenever you climb onto a bridge, you have to first cross a concrete slab. तो slab के नीचे filled up soil होता है. और उस soil को वहाँ पे basically to ensure that it is retained in that area, कि slab नीचे ना बैठ जाए, उसके लिए you put walls here कि soil अंदर ही रुका रहे. This thing it is also there कि because we don't want soil to fall over here or bearing के साथ interfere करे. So this wall here, it actually encapsulates the soil. This wall and dirt return wall, they both together encapsulate the soil behind abutment, so that it does not flow away or does not get washed away. अभी estimation के लिए first thing is, the first thing for any contractor is to be able to estimate the quantity of concrete in a bed. Concrete का quantity estimation is simple coordinate geometry mathematics, because your shape is very clear. ये इसको you can break down into triangles, rectangles, and you can calculate the area, and you know the width of the abutment 15,300. Multiplied by width, you get the weight of foundation. इस wall की बारी आएगी, and you know the wall का width is 14,200 plus 400 plus 400. ये wall की width 1000 by 2700 in this case. फिर आया cap. जो cap है, that is also extended from 400 plus 14,200 plus 400. इसकी width भी उतनी है, but इसका cross sectional area भी आपको निकालना पड़ेगा. वो भी थोड़ा सा ट्रेपीजियम और वो सब कुछ करके आ जाएगा. ऐसे ही dirt wall का भी आ जाएगा, ऐसे ही return wall का भी. So when you do all this, you'll get concrete का quantity कितना है. और one finer detail which is always there is that whenever they design this abutment, they will never give you height of pedestal.
Okay.
They will give you कि minimum height इतनी होनी चाहिए, maximum अपनी मर्जी से decide कर लो. वो इसलिए क्योंकि ये जो bearing होता है ना, इसका भी डिजाइन करना पड़ता है. बेयरिंग की हाइट बेसिकली बेयरिंग के ऊपर ब्रिज का ट्रस रेस्ट करता है, मैंने बताया था. तो जो ब्रिज के ट्रस का बॉटम लेवल है ना, दैट इज फिक्स्ड, बट उसके नीचे कितने पोर्शन में बेयरिंग आ रहा है और कितने पोर्शन में पेडेस्टल आ रहा है, दैट वेरीज अकॉर्डिंग टू हाइट ऑफ बेयरिंग. और बेयरिंग का डिजाइन लेट होता है, तो वो क्या करते हैं, पहले बेरिंग का डिजाइन करते हैं, उसके हिसाब से पेडेस्टल की हाइट। रिटर्न वॉल में कभी कभी दे एक्सटेंडेड लाइक बैक लाइक दिस, जैसे इधर किया हुआ है, इसको बोलते हैं विंग वॉल। इसका पर्पस भी सॉइल को ही रिटेन करने का होता है, बट इसको पूरा नीचे तक एक्सटेंड इसलिए नहीं करते हैं क्योंकि जो कोडल रिक्वायरमेंट के हिसाब से नीचे एक्सटेंड करने से कोई ज्यादा फायदा नहीं है, इसीलिए कंक्रीट सेव करने के लिए वो ऐसा ये बना लेते। ये हो गया हमारा, और नोट्स ये ड्राइंग का सेट भेज दूंगा। दीज टू आर दी this and this are the arrestor, and 4 bearings will go on top of here, and this is the abutment wall, this portion is the cap, and this is the return wall, and they are this is the foundation. As you can see here, you have some double bars coming out of foundation. I don't know what exactly the purpose to this, so I'll have to ask. This is, if you look at the drawings which I showed you, see how they had written 600 thick filter media, right? That is what is being placed. And what you see here are weep holes. What happens is that when soil, so you put this filter media all the way up to top, on back of it, you'll fill it up with soil. So as in when in future there is rain and everything, what happens is ki this soil will be filled with like it will soak up water. So these weep holes which are present here, and I think also on this return walls, they allow, so this filter media, the water passes through this filter media, it goes into the weep hole and comes out on the other side of abutment, so that if this is not allowed, then this water will create undue pressure on the abutment, which we do not want. We want the water to flow, and that is why this filter media is put, because otherwise this soil will clog the weep holes, the water will not be able to come out. So you put this filter media thing and weep hole is there. On site, you will actually come to know how is this shuttering done, because this entire foundation is not poured in one go. As you can see this mark here, this was the first lift, and then as you can like the shuttering is done here, they would have had put the boards here at this location, and then these arrangements they would have come at this location, so that concrete for this location would be done. After that, they moved it one more step above. If they put the boards here, they put the arrangement over here for concreting this portion. Now they are now this substructure part is complete. Now when bearings come, these pedestals will be poured, because the bottom of the bearing has to be fixed inside the pedestal, and that can be done only before concreting of pedestal.